We have a tremendous amount of new space, which actually gives us capabilities to do a lot of things that we weren't able to do before. For instance, we have now a glove box, which allows us to encapsulate specimens for other kinds of exposures that they might get, like for corrosion or for high temperature. We also have 3 new fume hoods, which allows us to do some chemical and corrosion type studies that we weren't able to do before. Also, the new space gives us a lot of new teaching space. We have room for benches and other kinds of things, so we can get a lot of students in there and do things with them where everybody's involved.
We'll be able to put our equipment in for testing out our solar arrays, for doing vibration testing of satellites where we shake them, much like they'll see on the trip to orbit. We'll be able to verify all of the systems and work with the ground stations as well. Having this extra room gives us the ability to also set up a ground operations control center named for Steve Nagel, one of our alumni astronauts. The control center will have multiple consoles, large screens, displays, and allow us to work directly with the satellites, allowing the students to serve as the operators and control the satellites directly.
It's really important for aerospace engineers to know what a composite material is, how to make complex parts out of composite. So that's one of the primary objectives of this new facility. But at the same time, anyone who needs to make composite part for some design project or for research will obviously come there too. So it's gonna have a dual purpose. But the objective is to make sure that none of our students can graduate without really knowing what a composite material is and what are the key techniques that people use to make complex composite parts.